All right, we've restarted the recording Monday, October 30th. I guess we have another day of summer type weather and before it turns cold. This, I believe, yes, this is module 10, which means assignment 10, which means week 10, which means the weeks are ticking off. Essentially, everything that we need to do is going to get done in November. There's not much to do in December in this class. So topic of the week is file I/O. We're going to talk about why that's important. And I think I'm going to follow the same pattern of having today be lecture day and Wednesday be work in Zoom breakout rooms individually. When I looked this morning, I had 11 out of 20 submissions in for project 2. If you're stuck on project 2 and want to talk about it on Wednesday, we can. We've made some changes to the schedule, which kind of affects what I was about to say about project 2. So let's go over those. We now have a new module 11 replacing the old module 11 and 12 to cover graphical user interfaces. And the module has been rewritten around GUI 0 as a graphical user interface system, as opposed to, I guess it was WX Python. Along with that, the powers that be created a new project, project 3. And the reason I want to mention that now is because that will change the weighting of the existing projects. There used to be 2 worth 40 points, 20 points apiece. Now there are 3, so each one is now 13 points towards your final grade. So it's not as much, but you still can't think about blowing off the projects and doing well in the class. So you can see that reflected in the schedule under getting started. One assignment got scrubbed and project 3 took its place. Everything else remains the same. Okay, any questions about that or flow of the class in general, where we are, where we're going? I noticed this morning that project 2 somehow didn't make it into the overdue list. I don't know why, but it is. And actually module 3 is missing here, but follow the course calendar more so than this, because for some reason things seem to be missing here. Coming up November 5th for module 10 is an assignment called the Restaurant Menu Editor. This is built around the same framework as what we did for project 2, but it's different and very dependent on file I/O. So that's why it's part of this. After that, we're going to move into our study of GUI environments, in particular GUI 0. We'll have a data entry form assignment due. And then the brand new project 3, which we'll talk about later. And then the final project, which is 2 things. One, it's back to the restaurant, and the other, it's a graphical user interface-based project. It's going to take you a while. We're going to try to allocate a lot of class time to helping you with it. We're going to allocate a lot of lecture time to GUI 0. The final project, I believe, is 20% of your grade. I think that is correct. If you blow off the final project, you're starting with an 80. And that means if the rest of your work is perfect, you'd still pass the course. Usually that's not the case. So I would not plan, as part of your being successful in the class, to blow away the final project. Blow off the final project. Okay, so topic for today is file I/O. And there we go. So let's see, we have 6 people in attendance, and excluding myself. Anybody Want to throw out any ideas about why file I/O is important? Okay, I have two ideas. One involves the data, well, both involve the data in your program. In project 2, for instance, we've coded the menu data into the program. That's a bad idea. Means that if you're going to change your menu, then you have to change the program. That's a bad idea. So by moving that data into an input file, we allow our program to read the data from the file and recreate the menu. You need to change the menu, you go to a text file, not to the program. On the other hand, the order information, which is 0 when the program starts, accumulates stuff during the day. When we get to do it as a GUI, we will accumulate multiple orders. And when the program exits, that data goes away. Well, corporate, for the restaurants, not happy that we've just lost all our order data. So by using file output, we can write that data out to a file and preserve it, email it, incorporate it into other things, put it on a network drive, all kinds of stuff. So data persistence, your data does not go away when the program does. And putting data into a data file rather than in the program are the two biggest reasons I have for it. Two different kinds of files. One is a text file. Now, for the people on the Windows side, when you think text file, you can think Notepad. Old, ancient, and not fancy. The only thing in a text file is text. There is no italics, underline, blinking. There's no fonts, actually no choice of fonts. It's just text. For those of you who have looked into Excel a little more closely than just preliminary stuff, may have found out that Excel can produce something called a CSV file, for comma-separated values. That is a text file. Can be read by Notepad. The only difference is that the data is represented in rows. Well, it's represented as lines in the text file, the same as rows in a spreadsheet. And the commas are used to mark off the columns to mimic the columns in the spreadsheet. So we will look at both plain old text files and we'll look at CSV files. The other side of the picture are binary files. And binary files have to contain the text information, but they also hold formatting data. Like it's blue, it's Helvetica font of this number of point, it's underlined, here's a bulleted list. There are lots of things that something like Word or Excel use and creates more modern looking, flexible documents than things like Notepad. Well, you have any Mac users who are on right now? No? Okay. I was going to ask the equivalent of Notepad in a Mac. Sure there is. So if you bring up a binary file in Notepad, you kind of see your data smushed in with a whole bunch of other stuff. But the intent is not to look at it as a text file. It's to let Word, for instance, look at it and do the Word kind of things with it. Similarly for Excel. So we're going to have today the unique privilege, because I don't think the other classes cover it, of looking at a Python binary file called a pickle file. There's two reasons to do this, maybe three. It's going to prove very useful for preserving data structures. It's really easy to use. And third, who can resist discussing a utility called pickle? I don't know why it's called that, but it is. If you put it in the back of your head when you get to study Java, for those of you going on to programming 2, I think you'll run across something called serializable I/O, and that's a very similar concept. So that's part of what we'll be doing. Now, these sections here are pretty straightforward and very good reading, but I see no reason that I should be reading it for you. I think they read pretty easily. The concepts in here aren't that fancy that they need a lot of explanation by themselves. But let's just take a quick review of what's here. This discusses kind of like the why is file I/O important. Things go wrong when you're doing file I/O, and try except is a very popular tool to handle the things that go wrong. Open up the order file from yesterday. We're sorry, that file doesn't exist. Oh, that's going to be an I/O exception. And we'll see examples of that. We want to learn how to read text files. We want to learn how to read CSV files. But before we do that, we're going to learn how to write text files and write CSV files. Why are we going to do that first? Because then we have something to read. So in the demo programs that we're going to look at today, we're going to write first and read afterwards. So that's the plan in general. Just because I'm not going through these sections doesn't mean that you shouldn't spend some time, like an hour, going through these and seeing what's there and seeing the examples. In addition to which, several years back, I created some demo programs for this module. They cover these topics and then some. They have a little bit of a different flavor to them. And of course, I like my programs more than I like other people's programs. So I decided to put those programs into the course. And if you click on that and you're logged on to a Deltek account, this is on the school's Google Drive. You should see these files. And if you click on any of them, let's see, where are we going to start? We're going to start with writing demo 1, double click, I guess. You should get code, and that code can be copied and pasted. So here are examples that you're free to use. I posted them. They're not proprietary. They're free to use for concepts. So what we're going to do pretty much for the rest of the class is just to go through these programs in certain order and make sure we understand where the pieces are and how they fit together, and make sure that the program that we write, the file that we write is available to a program to read. And of course, the read should successfully recover the data. So first up, text files. Second, CSV files. Last but not least, pickle files. So that's where we're going. Anybody think of any other reasons that data files are a good idea? I thought of another one. What about if your data is massive? And whenever I think about massive data, I think of like any government agency has millions of pieces of information, for instance, IRS. That information, number one, has to be persistent. And number two, you can't store that amount of information in a program. So, so that's another good reason for having files, although those files are not text files, they're binary files. And it's in our best interest to be able to read and write those files from Python or any other language that we choose to use. Anybody who's on now taking the database class this semester or previously?
Yeah, I'm taking it.
Me too.
Okay. Database files are binary. They have not only data, but they have structure, and they are understood by the database management system that created the files, can write them, can read them. We don't have the time, but we could easily spend a week or two discussing how to read and write relational data into these database files in Python. I wouldn't say it's easy, but it's doable. It's not that hard, and there's tons of examples. So if you're interested, that's something you could look at on your own. And if you'd like some guidance or some direction, we could do that on the side. So database files are binary, but there are tools in Python to let us get to them. Particularly, the thing that comes up on the job tends to be anything important is stored in the database. And the database management system does a certain number of things, and it does it really well. But the organization sometimes wants other stuff. Can you take this data and tell me this and that? Or can you take the data and send it somewhere? Or can you validate such and such? So a lot of work has been put into being able to connect with Python and other languages to be able to connect to a database. Most common databases follow a almost standard convention called SQL for structured query language. And once you've connected to the database, then the code that you write in SQL is not that much different from one database to another. Having said it, the connection to the database from something like Python or Java can be tricky, and there are multiple ways of doing it. So, yet another example of binary files. Just a hint on the side, if you want to make a bunch of money in the field of IT, database manager is a great thing to do. You end up with a lot of company critical information and systems tied around a database. So how to configure it, how to figure out bottlenecks, how to back it up, are all critically important things. And database management systems tend to have their own, in addition to SQL, which is not a full programming language, tend to have their own programming languages dedicated to the database. Interesting course of study. Another thing that maybe not quite to the tune of database manager that's comes up and tends to be well compensated is the ability to write a program to read and write to spreadsheets. Why? Because spreadsheets are not programming. Actually, I think there's now ways of writing Python behind Excel's back. But just pure Excel isn't programming. If it is programming, it's not a great program. There's limits to what you can do. It's very easy to create confusion. Doing certain things requires a lot of work. And Excel has, in my lifetime, forever, no, not in my lifetime, in my working lifetime, forever supported a programming language behind it called Visual Basic, or Visual Basic for Applications. And that was a true programming language with hooks into and out of Excel. So if you as a programmer can read and write Excel format, then you've got an edge up over some people who can't. The easy way in Python is CSV, but then you have to make sure you have a CSV representation of your spreadsheet. Python has tools for directly reading Excel binaries. And if you're interested, I'd highly encourage you to research that. And again, well, although I don't remember them off the top of my head, I'm sure I could come up with them pretty easily. Okay, let me turn on my fan because the room gets warm. And let's start looking. So from here, we're just going to go over to PyCharm. And in PyCharm, I've got, I guess, all of these files out in D2L. Certainly the important ones, which are the PY files. And as I said, we're going to go through these by writing first and reading second. And in the case of plain text files, I'm going to do it in 2 versions, CSV files in 2 versions, and then just 1 pickle file. So let's get a first start. Number 1. This kind of like that. Okay. One of the things that we're going to see today is that the print function, and how do we know that print is a function? Because it has parentheses. Is it a built-in function? You bet it is. The print function has some magic that we may not yet appreciate, and it has some extra capabilities that we may not yet appreciate. But hopefully after today, we will. So it's not a bad idea as a global variable, which we declare to be a constant by putting its name in uppercase, to declare where the data is going to be held. PyCharm recognizes a limited number of extensions. It certainly recognizes TXT, and it recognizes CSV. So if this is a plain old text file, it's to our benefit to give it a .txt extension. Do we have to? No. But if we don't, then the operating system and PyCharm won't know what type of file it is. Why do I make it a global variable? Just because it's up front. And if this had multiple functions in it, then this variable, which is a constant, would be available to all those functions. So you know me, I'm all about def main to contain my code. And that's the only function here. And I have a message. I have 2 messages that I'm interested in. We already talked about the first one. Anybody with a brilliant memory remember where the quote is from? The rain in Spain falls mainly in the plain. Nah, I wouldn't think so. I have trouble remembering it. It's a musical, My Fair Lady, which, as last time, I promised I wouldn't sing for you. Message number 2 is no one expected the Spanish Inquisition. Anybody know where that comes from?
Monty Python.
Say again?
Monty Python.
Absolutely, yes. And one of the cutest YouTube videos I ever saw is somebody trained their parakeet to actually say no one expected the Spanish Inquisition. Just precious if you're into parakeets. Now, maybe those messages should have also been global up here, but it doesn't matter. Okay, so no new news yet. Now things get weird. We need to create something called a file handle. It's a certain type of variable that's capable of doing file I/O. But it needs to be created. It needs to be created as an object. And it is created by a standard Python function called open. And open needs at least, well, open really only needs one piece of information, which is where is your data? Usually because, well, usually for me, because I can't remember defaults, you have a 2-character code over here telling you what you're going to do and what type of file. So WT stands for write text. Of course, there's R and W, there's T and B. And then in D2L, there's a whole bunch of other things that you should at least know about or know where you can find them. But for what we're starting out with, RT and WT. There is a default, which is probably RT, but I can't remember it. So let's see, if we hover over this, it doesn't say a lot, does it? It says it's a text IO type of object. That's how it was formed. Okay, so this is good because we can now take that object and we can use a Python function called write, which doesn't have a lot of information along with it. And it basically writes text using the file handle. So the handle tied it to the file, .write gives you a message. And for some reason, it's necessary to include after the message a new line character. And we'll find out why in a little bit. And if for some reason you want another way of doing it, we can do the same thing with print. Well, wait a minute. Print just means print to the console down here on the bottom. What's this have to do with file I/O? Well, it's because print as a function supports a parameter that we haven't used yet, and the parameter is file equals. If we say file equals, then instead of being printed on the console, it's printed to the file represented by the handle. And now we begin to see some weirdness. No \n, right? The \n is provided to you by the print statement. We've just never looked at it before, or thought about that before. But the only reason that you get a new line in print is because of the way the print function is written. That ain't necessarily so. Now that we're done, this handle has to be closed. Well, what does that mean? And why do we have to do that? So assuming that people still have some knowledge of USB jump drives, true or false, when you're done writing to one of those little USB sticks, you just pull them out of the computer and you're done with it. Is that true or false?
You're not supposed to.
You're not supposed to. What are you supposed to do?
Eject it.
Right. And why is that important? Well, the truth be told, is much more important for writing than for reading. And the reason is that file I/O tends to be slower than the program, and the operating system tends to buffer the I/O to try to not slow everything down. When you're done, those buffers have to be flushed out to the device. If they aren't, you've corrupted your data. So that's what eject does. And that's what .close does, is make sure there are no more memory-based buffers of information waiting to be written out to the file. Reading, not so much, but it's not a bad idea. So if we, let's see, data.text. Let's just make sure I'm going to get rid of this file. I probably should get rid of all of my data files. Let's do that. Oh, I missed one. So we know we're on the up and up here. Okay, all of these are now program files, no data file. There's another good reason for doing writing first, and that's to find out where is this file going to appear. Now, Python takes the obvious answer to that. Let's run the program. There should be no I/O to the console. There is none. But there's a new file called data.txt that is written to the same directory as the program. And that's a big clue. So without any path information, Python will read and write from programs in the same directory as the program. Java will not. Java will read and write to the project directory, not the directory where the program is, which is a big surprise if you were expecting the file to show up here. So excitement builds what's in the file. Okay, the same thing written twice. But you can see that we did it in two different ways, and that this way needed a \n. So it's fair to say if we take out the \n, at least here, that we will see the way write performs which is just keep writing data. You know, you don't need to have a \n to have data written out. You may want to, but you don't need to. So without \n in write, everything is in one line. And that's fine. The question becomes, how do I ever separate out those lines if I was going to write everything in one line? And the answer could be to write a symbol that you never are going to use, like maybe a pipe symbol. So now I have pipes separating my lines, but everything's in one line. Just so you know that you can do it. Now, I have a bright idea. Why don't I use a comma to separate these things? And the answer is maybe your text has a comma in it. And we'll talk a lot more of that when we get to CSV files. So any questions on what we have here? No new imports. Name of the text file. Some messages. Text. A file handle. Open. Handle.write or print. File equals. You're done. Close the file handle. That's it. Questions? We're good? Okay. Since this idea of closing the file handle is easy enough to forget about, and for writing, it can cause a problem, not recently, a while back, there's been an alternative proposed to the technique of open and close like this. And that's in the second version. So that's right. Number 2. And this goes by different names. Python calls it a context manager. I think Java calls it a resource manager. It really looks the same. So just to be aware. Okay, so I violated my own rule. I don't have a variable for poem.text. I put it here. Who can tell me anything about limericks as a style of poem? No? Okay, you've led a sheltered life. Limericks have a definite rhyming style. It's da-da-da-da-da-da, da-da-da-da-da-da, da-da-da-da-da-da-da-da-da-da-da. So when you see that rhyming style, you know it's a limerick. And for some reason, limericks also tend to be off color. So that means that it's a natural to start with, there once was a man from Nantucket who kept all his stuff in a bucket, and figure out what the rhyming style would be. From our perspective, all I wanted was a multi-line string. So I used 3 single quotes because this is not a doc string. I used a backslash so I could put everything here, and here's the end of my multi-line string. Not much here, huh? With, that's the context manager. Open, we've seen before. As is a new keyword that matches up with with, and here's the file handle. And this is a code container. It ends in a colon. Line 20 must be indented. And the good news is that when we're done with the code container, that the context manager closes the file. So not your worry anymore. This gives us another structure within our program, so why not? And you never have to worry about closing the file. And that's it. So let's run this program and see if we get a file called poem.txt. We do. And if we look at that file, notice that PyCharm understands how to display the file. It knows to display it as a text file. We can actually edit it here also. 2 lines, well, a total of 4 lines, and everything is cool. So the context manager becomes the preferred style, in my opinion. The D2L notes kind of get there, but I don't know if it gets there clearly enough. All right, so we've got two files in the directory with the programs. Let's try reading them. Let's see what happens. So let's get rid of this. Let's get rid of this. We can leave those there, I guess. And let's try reading the file. Okay. Read multiple lines from a text file and append it to the list and then print the list. Okay. So there's my doc string. Here's my data file. What could possibly go wrong? Well, the biggest thing that could possibly go wrong is that the file doesn't exist. So if I showed you this program first without having run the matching writing program, the file would not exist. That would cause an exception. The exception is called a file not found exception, file not found error. And I can alias that to an E, which we haven't done before, only because that will allow me to print E, and I'll show you what that is later. Okay, so old-fashioned way, open, close. File handle, well, it's an RT, not a WT. So we told open that we should be reading this as a text file. Now, somebody should have had the question, what if you want to read and write at the same time? Well, there's a code for that. Look it up in D2L or look it up online. What if I want to append to a file instead of just writing to it? Same thing, there's another code. So the contents of the file is going into a list. That list better be empty to start with. And now I have a loop. And I think if you look at the Python cheat sheet, you'll see this as a recommendation. But you will see several of the things we've been talking about in the Python cheat sheet. For each line in the file handle, well, what does that mean about the file handle? It means it's iterable. I can use it in a for in statement. And each thing that I get, one at a time, will be assigned line. There's nothing sacred about the word line, but it's descriptive. And then I can append that thing, which could have been called George, or our ever popular Larry. No, Daryl, Larry and his brother Daryl and his other brother Daryl. Whatever you want can be appended to this empty list. And when we're done, we're going to print out sayings. So let's just do that. And let's just look at the top line. And what do we see? What is sayings? It's a list of strings, list, open square bracket, go to the end of the line, closed square bracket. And in that list, there are, oh, I kept the pipe in there. Oh, I didn't write the file again afterwards. Anyway, phooey. Okay, let's go back to write. I've messed up my example. Blah, 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 blah. Run the program, back to reading, run the program. Okay, there we go. What's in the list? Well, the first element in the list is a string. And then comes another string, and then comes another string, and then comes the fourth string. So the file is got 4 lines in it, and they each end up as an element of a list because we do dot append as the only thing in this loop. All right. Everybody doing okay so far? Okay. Well, that's fine, but it's not user friendly. So what we really need to do is we really need to go through here again. And we need to print these things out in some kind of a friendly fashion. Well, if the list is called sayings, then I can write a loop that says for saying in sayings, and I can print each saying. Pretty straightforward. And what do I see? I see extra blank lines because they already exist in the file. And the ever-friendly print statement says, after everything you print, give me a blank line. So now we have 2 blank lines, and now we discover the next thing that has been a secret, and that is that print supports another parameter called end. And if I make that nothing, then it will not print a new line. It will print nothing, and the new line already being in the file makes this come out correctly. Questions? We're good? Okay. We're done. Close the file. All this program does is read. Can we get away with not closing it? Probably, but it's bad style. And as you can guess, in demo 2, we will do it the smart way, not the stupid way. Well, close all of them. Okay. Oh, we did. Did we do this? Did I show you the context manager for this? Nobody knows. Just in case I didn't, we're going to write the same file with a context manager. The file is the same with open, blah, blah, blah. And then just write out the variable, which is a multi-line thing. Okay, so now I showed it to you. So how do we read this? Well, we're going to use, I said resource manager. It probably should have been context manager. So be it. With open, get each line out of the file and print it. Well, we know that if we print it, we're going to see an extra line feed. And we're going to get blank lines. Well, not if we do a .r strip. .r strip says strip something off the right side of the string. And if you don't tell it what, you can hover over this and find out that what will strip is white space. Well, what is white space? A white space is a space, a tab, and a new line. So that kind of does the same thing. We don't have to specify end equals, although we could. And what is our exception? Well, it's a file not found error, which we printed that out. What I didn't do is I didn't show you that E in the other example. So let's just throw it in here as E. And let's find out what happens if I print E. Is it printable? What does it say? How do I get the error? I screw up the name. That file does not exist, does it? Nope. So here's what I printed, file not found, and here's what E is, error number 2, blah, blah, blah. So if you don't want to come up with your own description and you don't want an exception, then you can create an alias here and print that, and you'll get this, which is not quite as friendly as this because it begs the issue of what is error no 2 about. All right. So we're good. Okay. Questions? Comments? Pretty easy. Is anybody worried about this yet? Okay. Now's a great time for a break. because after the break, we're going to look at CSV files and we're going to look at pickle files. So IC 915, 916, why don't we say 925? And we will go ahead and look at CSV files. If you want to try this out with Excel, just remember save as CSV. Excel will automatically read a CSV file. Well, if it's associated in your operating system, which it probably will be. Okay, welcome back. Any questions on reading and writing simple text files before we move on? Okay, so now we're going to do the same thing, but with CSV files. And the first question that could come up is, what's the big deal? Why don't we just separate our fields with commas? Why do we need to import a special module to do this? And the answer is that things can get weird. So in my simple example here, I put a comma, excuse me, I put a comma into a data field. Now, I don't think Mickey Mantle did have a junior after his name, but I don't know much about sports, don't care. But I wanted to make a point. That CSV module knows about stuff. And PyCharm knows about CSV files. So it's a beautiful thing, and we will see that as we go along. Not a very big program. The data is a two-dimensional list, except the two-dimensional lists don't exist. Two-dimensional arrays exist, but that's a different story. It looks like a two-dimensional list, and if we hit enter in the right place, it looks like a spreadsheet. And it looks like, excuse me, first name, last name, and lifetime batting average. I actually looked these up, but I don't remember if these were the right numbers or not. But again, I don't care. And they're people whose name I remembered from baseball. I think that Mickey Mantle used to live in the same town that we lived in New Jersey, but who cares? So a list of lists, a resource manager, the name of the file, we're writing it as text, and something new. I need to say new line equals empty string, or else I'm going to get an extra line in there. Going to establish a file handle. But we know from before the break that these handles are good for write statements and print statements. They're not good enough for CSV. So we have to go to csv.writer, pass to it our file handle, and essentially get back a CSV out handle, or CSV handle, suitable for writing. So what can I do with a CSV handle suitable for writing? Well, several things, the easiest of which is write rows. So CSV, I always want to say CVS, CSV is smart enough to recognize this as appearing to be rows and columns. So it interprets write rows correctly, writes that out, creates a file called players1.csv, doesn't exist now. Run the program, it does exist. Get excited, double click on it. How about that? Ain't that amazing? I think this might be an extra add-on into PyCharm that shows the colors, but you can poke around and find it. If not, it will show you something. So PyCharm says, I'm going to show this to you as rows and columns, and I'm going to color code the columns. CSV module says, you can't fool me. This is only one piece of data, even though it has a comma in it. So there's some aggravation that you don't need to face. And it doesn't tell you what type of data this is or that. So let's take a look back at our file. This is actually integer data and this is string data. So that'll come up later, we'll find out. Especially if we need to do something numerically with the lifetime batting average. So not really a big deal. I mean, the only new exciting part here perhaps is the with statement and of course the right rows. Questions? I wish somebody would nod and say, yeah, that's pretty straightforward. Let's move on. How do we read it? Okay, I want to get a little more adventuresome here. And I want to show you how you can use a CSV function called dictReader, dictionary reader. It adds some extra smarts to what we're trying to do. So CSV module, open it as a text file for reading. Don't read anything else into these files. They're just text files. File.in is the handle. It gets passed to the dictionary reader. And now, because we're using dictReader, we have the option of giving, well, we're required actually to give it field names. So for those of you taking the database class, we'll start to see certain things come up, like the idea of fields. So these are the fields of the database guys: first name, last name, batting average. Excel people, these are column headings. So be that as it may, and we'll find out what they are in Python in a moment. Okay, so if I print CSV in, I would kind of guess that I'm going to see a dictionary. So let's just go that far with it. And let's just read the, oh, no, actually. Line 17 is what showed me this, which is amazingly unhelpful. I can't just print CSV in, because all I find out is it's some kind of a dictReader object. And now I have the unique privilege of knowing what memory location the object exists at. So that's a hex address. Who cares? So that's a fail. I just put it there to show you what you would get if you printed it. So I need to do something else. I need to do this. And I guess there's at least one person in the class who used this idea in a program, which is a really neat idea. What is this? Well, let's see. What is players? What does PyCharm think players is? It thinks it's a list of strings. So the square brackets create a list. And inside the square brackets is something called the list comprehension. And you recognize things like for in. That's a loop. Well, where's the loop? The loop is built in to this list comprehension. And it says, for every row in CVS in, just create a variable for that row and make a list out of it. Well, that's nice, but there's more to it. You can actually not only use row, you can use this as an expression, and there's a where clause that you can apply to it if that's applicable. So it's going to create a list, and now when we print the list, we should see something more usable than the memory location. We see a list, right? What's inside the list? What does that look like to you as a data structure? I should just stop talking till somebody gives me an answer. If you see a thing with curly braces and colons, you should say starts with a D.
Dictionary.
Dictionary, yay! Da, 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 da. You win the prize. It's a dictionary. It's followed by another dictionary, which is followed by another dictionary, which is followed by the end of the list. So in Python speak, this is a list of dictionaries, and each dictionary represents a row in the file. Yes, yes, 3 of them. And in each dictionary is the column heading or the field name as the key. And these have to be unique keys followed by the data for that key. Now, I will say, or I will admit, that some of you who use dictionaries for this week's assignment follow this style of field name colon value, which I hadn't thought of when I first did that assignment. I like it. It provides a nice orderly way of dealing with things. So if you want to take a look at the way in which the dictionary reader made this, I think there's some merit to it. So field name value. Does the values have to be unique? Of course not. But the field names do, and they represent the fields or the columns, first name, last name, batting average. And we can see here that everything has been made into a string. So if we're going to use this numerically, we have to convert it to an integer. Okay, so great information. Whoops, great information, a list of dictionaries. Thank you very much. But not user presentable. So what are we going to do for user presentable? I don't know. We are going to write a loop. And the loop is going to be for each player in players, which we know is a list of dictionaries. For each of those dictionaries, we can do for key value in that row dot items, print out the key colon item. Now I can't get rid of this warning. I'm not sure why it exists. PyCharm is confused about something. This is the right way to do it, but it's not perfect. After you do this, then after each thing here, then make sure you go to the next line. And now I can get my records printed out. So database people, here are your records. Excel people, here are your rows. Database people, here are your fields. Excel people, here are your column headings. Here's the comma over here. We don't know that this is a string, but we don't care right now. And it's pretty. So I get rid of these prints, and this is what I deliver to my customer. Okay. Questions? Comments? Yawns? Applause? I'd hold your applause until the next one. Actually, I hold your standing applause until we get to the pickle files. That's worth a standing applause. What makes this work? Dict reader. Dict reader is what makes it work. Where is it going to get the keys from? It's going to get it from the parameter or argument field names. And what is it? It's a list of column headings or a list of field names. Okay. This file looks a little sparse, right? No column headings. You expect in Excel to find column headings. You may or may not find row headings, but at least you expect to find column headings. So let's try again. Let's try again. Let's do a write version 2. And remember, these are yours to use as you see fit. Write a CSV file with a header using csv.dictWriter. And the data is going to be a list of dictionaries. Well, duh, that's what we just saw. Here's players expressed as a list of dictionaries. So I am writing, this is my data. I've organized that data as a list of dictionaries, the key being in each dictionary, key being field name, data being the value. Okay. Open the file, second version, no new lines, handle called file.out. Use it for CSV dictWriter. It needs to know the field names. I tried not doing that and it didn't like it. So that's kind of redundant information I have to give it. And dictWriter is so smart, it can now do write header. I assume that all it's doing is getting that from this list. So write header followed by write rows. We feed that with our list of dictionaries. Now, at this point, if you've embraced the idea of a dictionary, you should have a big grin. Here's a great use for dictionaries, as there are many others. Without knowing what a dictionary is, this whole concept really doesn't make sense. And that's it. Run the program. We create a new file, new CSV file. And bingo, we're looking a lot more like Excel. Heading, column headings, comma separated, and 3 records, 3 data records, or 3 rows underneath. So let's be brave. Why not? Let's go and open this in File Explorer. Now we're looking at the Windows representation of this. And since for years, decades, I have boycotted Microsoft Office and gone to OpenOffice, that's what is associated with .csv. It's not PyCharm in any which way. So if I click on this, double click it, it should open up, well, LibreOffice is a different story. Yes, I'm using LibreOffice, not OpenOffice, but it's an OpenOffice format. This says, hey, I'm going to do text import for you from CSV. Do you want to monkey around with it? No, not really. And there is, let's get bigger. No, it will. Cool. There's a spreadsheet with column headings. I want to save it as a spreadsheet. No big deal. Just go under here and do save as, and I can specify things like XLSX and save it out as a spreadsheet, or a bunch of other things. All of that for free. So take that, Microsoft Office. And of course, if I had this and I generated a CSV file, I could have read it with Python. So let's get rid of that. Let's get rid of that. Okay, so how do we recover this file? Well, we use dictReader. And as a matter of fact, I don't see any changes to this. Let's see what we get when we run it. I did print out the junk. Now, how is that different at all from this version? Not really. Looks pretty much the same to me. Okay. Uh, I'm curious about how this avoided reading the header. Yeah, I have to think about that. I'm not sure why this didn't read the header and we had to tell it to ignore it. But it didn't get it upset. Okay. Questions? All right, let's put that away. And let's take our last topic for today, which should mean we should get finished early. And that is written around this. Okay, what's our data structure grades? What is it? Come on. Starts with the letter D. Boy, what I wouldn't give to see if people are sleeping or just dazed.
Is that also a dictionary?
Sure, it's got curly braces. What are the keys of the dictionary?
It'd be the names.
Yeah, it's a list of names. Not a great idea because we have duplicates, but this is just an example. What's the values in the dictionary?
The integers.
Yeah, but those are inside of a structure. The values are actually, each value is what? Starts with an L. Second letter is I.
List.
List, yes. So this is a dictionary with names as a key, lists as a value, and each list happens to have 3 numbers, which are either integer or floats. No biggie, right? I just needed something simple. Now I'm going to do with open, write binary. And I'm going to specify the name of a file and tell you that PKL is not sacred. It's not associated. You could call it whatever you want. It stands for pickle. But I don't think anybody recognizes it as anything. And what are we going to do with the file handle? Well, we're going to do pickle, which we imported, .dump. What are we going to dump? We're going to dump a data structure into the file handle, and that's it. So let's look over here for grades.pkl, and we got it. And let's open this, and we see garbage. Well, yes and no. We see Mary, Barry, and Harry, and some other stuff. But basically, we're not supposed to be reading this. It's a binary file. But we have to have faith that pickle.dump knows what it's doing, right? Although we can't read it, that doesn't mean it's useless. So this is my choice of data structure. You could have created whatever kind of data structure you want and then pickle it out with pickle.dump to a file. Well, what good is it? And the answer is outside of Python, not very. Inside of Python, we have the opportunity to read a pickle file. Of course, we need pickle. We need a file handle to be read in binary. And we're going to create in this program. Notice this is the first time grades has been mentioned. We're going to create something in an assignment, and on the right side is pickle.load. The other was pickle.dump. And we are going to load things using the file handle. I should have done a try except, I didn't. And once we've loaded this, let's see what we can do with it. Well, we can format it. Grades.items, and we're going to break that up into student, which is the key, grade list, which is a list. We're going to print the student name, and then we're going to tab in. I don't remember exactly what that looks like. Oh, just tab in. Don't do anything else. And then go through grade list. Remember grade list. That's a list of grades. Go through grade list and tell me about each grade. And that grade is going to get printed in an F string, right justified, 5.1, floating point number, space, and nothing at the end. But at the end of this loop, then go to the next line. So think in your head what this is going to look like and see if it matches your expectations when I hit the run key. Pretty cool, huh? There we go. Okay, so this print statement printed Mary, Barry, and Harry. It printed a colon. It did a new line. On the next line, we printed a tab, and notice, well, that's interesting. The tab looks like 5 spaces, not 4. Okay. We printed a tab, and then we did nothing. And then we went into another loop, printed each grade with a space after it, and lined them up in a field 5 across, and 1 digit after the decimal, which for a grade, that's about all you really care about. I, of course, could have gone and figured out either averages for each student, averages down the columns, kind of begging the issue about why didn't I do this? And the answer is, I don't know. That looks fine to me. Now, the magic here is the fact that grades, which did not exist until line 13, was created and structured as a dictionary of lists. How do I know? Because I could go through it here in a nested for loop and pull things apart. So pickle.load not only has data, but it has structure, data structure, and we'll recreate it. That means that you could send it to, well, I did. I sent it to another program. I could somehow transfer it to another program and not have to create the structure. So if I didn't have pickle, yeah, oh boy. If I didn't have pickle, I'd be in a pickle. I would have to know what the structure is. I'd have to set up an empty dictionary, and then I'd have to recreate the structure using loops for rows and columns. Pickle does it for you. Hard to use? I don't think so. What do you got to remember? You got to remember read binary and write binary, pickle.load, pickle.dump, put it in a open with resources, and you're done. So why is this not a topic that people cover given 15 minutes or so of class time? I don't know. We got to the end of that. So questions? Comments? If I had thought ahead, I would ask you to give me an up-down vote on pickle. I like it, I don't like it, or I'm not sure. Any comments? Like it, don't like it, I'm not sure. Okay. Questions on today's material? No. Oh, I know what I almost forgot. I'm not done. We got to talk about the assignment, don't we? Yes, we do. We have to talk about the assignment. Hey. So we're back to the beachside restaurant. I don't know why it's not capitalized. They were thrilled with your menu program. They were not thrilled that the program had data hard coded into it. So in this assignment, you're going to create a different program, and this is going to be an editor program. That means that you're going to get, this program is going to give the manager the ability to change the menu without changing code. When you're done, you're going to write your changes out to the menu file. So this file would probably be called, well, it's up to you. You're going to have to choose the type of data that it is. I'm guessing it's either going to be a dictionary. Well, my guess is it's going to be a CSV file. I think that's a fair guess. So what do you need to do? Well, you already have an example in your program, assuming that you've done project 2, of a menu list of lists or a menu dictionary. If you don't, you need one or the other, or else you're not going anywhere with this assignment. So each item of data, which is each item in your menu, which is each row of your menu, has a short code for the item, short as you could get, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You want to break it up into drinks, entrees, and sides, D1, D2, D3, like that. Maybe not such a short description, but up to 25 characters of description, and a unit price for the item, which should be a float, because it certainly could have a decimal. So what are we going to do? We're going to read the file and create a data structure that's appropriate. Remember, these are text files. There's no data structure in the text file. If there's no text file, then you're going to start with nothing. And that's okay, because on day 1, you are probably not going to have anything. Well, no, it's in your program, isn't it? No, the whole goal of this assignment was not to have your menu data in your program. Now, this is a biggie, this step. You need the ability in your program to add, edit, or delete items from your menu. Okay, so from the program's perspective, we've said add, edit, and delete. From a database perspective, I think the right words are insert, delete, and update. Regardless, you need to provide a little menu that says, what are you trying to do? So depending on which you choose, depends on, what logic appears after that. If I'm going to add, then I need to think about generating a new short code. If I'm thinking of editing, then I better specify an existing short code, and I better provide a description and a unit price. If I'm thinking of deleting, then I better provide a legitimate short code. So add, edit, and delete each has their own flavor to them and needs to be followed. This can go on forever. And when you're done, you now have a data structure in your program that could be written out to the file. Now, is there anything here that says that this can't be a pickle file? And the answer is, I guess not. So I can't show you the concept and then say you can't use it. That's not fair. So I guess your two possibilities that I can think of off the top would be your file can be a text CSV file or a binary pickle file. This is going to take a while, which is another good reason to devote the day Wednesday to working on it in class. This breaks down into pretty much a convenient set of pieces. The first thing we need to do is we need to read the file and recreate it, create or recreate the data structure. We then need to provide a menu. We probably want to show the user the menu. Then create a menu that allows you to add, edit, and delete, or done. And when you are done, you write out your revised menu back to the data file in whatever format you read it in. All right, so most important question, do you understand what the assignment is? Not how to do it, but what we're asking you to do. Cool. All right, so before I stop the recording, any other questions on what we've talked about today, including the assignment? Cool. So remember, asking questions is a sign of strength, not a sign of weakness. And if there are things that you aren't sure about, probably half the people in attendance are also not sure about it, but they're too shy to ask. Okay, so I will pause the